Hey, this is Gary, and welcome back to my channel for making a 2D game framework off of LibGDX. So in this video, I'm going to get more into the layers that I mentioned yesterday. One of the things I'm also going to do is I'm going to combine my simple screen into my base screen, because I'm going to use a concept that I call GameMaps to handle the rendering of the sprites onto the screen. So everything that I've got here in my simple screen is going to be moved into my base screen. Okay, so I've added the add actor. Right now it's just calling the add sprite. I added the render child method, and then I added the add sprite and detect collision. And so now we can delete our simple screen. Updated our tutorial, so now everything extends our base screen. And we'll do a test, make sure that's still working as expected. Yeah, there's our background and our sprite that we can drag. Now the next piece I'm going to do is add layers to our sprite. So then our sprite will be sitting at different layers so that we can render them kind of a depth front to back. And so that's just going to be an int for our layers, since your sprite's going to be either in one layer or the other. And then we'll also give our sprite a depth. And then we also need to update our bounds to include the layer. So we're adding the set layer to our bounds. And then a bounding box will also need that method. And we'll add the layer to our constructor. Then we update our contains for a point, make sure that we're on the same layer, and we check our X and Y. We add our setter for the layer. We add a getter, and back into our sprite, and we'll set a default layer of 0. Okay, in our sprite update, we're going to add layer as well. We'll add it to our contains. Getting a layer and setting layer are added. And so here in our sprite, we just need to add the layer here and add layer here. And we're going to add a new method. Boolean is changing layer. We're going to turn false for right now. And now we need to make some updates to our actor. So now our actor can change layers. So we're going to add a changing layer flag. We're going to override our is changing layer. And we're going to be returning our change in layer flag. And then we update our handle collision. If we're moving our sprite back, then we changing layer will be set to false. In our update method, we get the current layer, we do our movement update, and then we check to say if our starting layer doesn't equal the current layer, then we mark that we're changing layers. Now, since we're going to be operating on sprites with different layers, they potentially could be over each other, and we don't want the click actions to interact with more than one sprite. We just want it whichever one's kind of locked on. So we're going to create a new object called input locks, and it's just simply a object that contains a map of what we want to lock, and we're also going to keep a list of what we want to remove. So when we add a lock, we're going to add the input key, the sprite that it's going to be locked on, and then if the removes contains that, we just remove it from our removes list. I will get into how the removes works in a bit. And then we add our lock to our sprite. So we have a method to clear out our remove. So what it does is it goes through our removes, goes into our lock map and removes all those entries. Cancel remove, that if we know that we're going to cancel the lock, we have like a collision, so we want to reverse that cancel. So we do our cancel, so we just remove it from our remove list. We add a check to see if it's locked, where you just pass in that ID and see if it is locked. And then we have is locked on. This is just to check to see if it's locked on this particular sprite. Remove method just to remove a sprite from being locked, and remove all will take all of our locks and add them to our removes. So this input locks works with our screen inputs. And so here in our screen inputs, we have a input locks. It's static. And so we've added a method for a mouse click if button just pressed, where you pass in that button ID and the sprite associated with it. And then so it checks to see if there's a lock. If there's no lock, then it just returns the buttons being pressed. Otherwise, it'll check to see if it's locked on that sprite. And if it is locked on that sprite that's being passed in, then we check to see that the button has been pressed. Otherwise, we'd return false. And then this is the implementation for the button pressed. And it's a similar pattern of if there's a lock on it versus there's a lock with that sprite. Now that we're locking on the sprite, so now our movements need to know about the sprite. So we're going to add a method to our movement to get the parent and set the parent. And then in our base movement, we're going to add a parent sprite and implement our getters and our setters. So back in our actor where we're setting our movement, we call the movements.setParent and we pass in this object. And we update our constructors to call that set movement so that that's taken care of for us. So in the no movement method, we override the getters and the setter. No movement, it's not going to block on anything, so it's always going to return null, and you're not able to set anything. Script movement doesn't extend that base movement, so we implement the parent within this class, adding the getters and the setters accordingly. Now in our mouse drag movement, this is where we're actually using the button to click to move the sprite around. So what we need to do is update our code to use screen input dot is button just press, passing in that parent. And then if it's a button activated and we're active, then we're going to add our lock for this particular sprite's movement. And if we're deactivating that button activation, then we're going to remove the sprite from it. Then in our render method in our base screen, what we do is here in our loop, we're looping through all of our updatables, we're rendering our child, and then after we complete that, then we go into our input locks and we call that clear method so that anything that we remove the lock from will get cleared out. So there's a two-step process in removing a sprite from a lock. The reason for that is because if you have a sprite that's over another sprite and you're clicking to deactivate it, and then if it's going into that same layer, you're going to get a collision, and then you need to kind of reverse that of unlocking your sprite. But if you take that lock off too soon and the other sprite updates, he will then get the notification that he's just been clicked. And so that's why we have to do this in a two-step process. Now that we have all the pieces that we need for our layer movement, we're ready to create our new class, our mouse layer drag movement. This will just extend our base movement. Okay, we need some basic parameters. We'll need our layer direction if we're going to be clicking and pulling it up versus clicking, pushing it down. So you get the option, most likely you just be clicking to pull it up. Whether or not our button is activated, whether or not we're triggering our click, I'll show you how that works momentarily. Whether it's going to be button activated, we have our button ID, our click offsets, our update locations, and our starting X and Y locations. And I'll show you how that's moved. So there's some overlap between this and the mouse drag movement. And so at some point I will create a base class for mouse movements. I'll do that later. Now I mentioned the movement directions going between the layers up a layer or down a layer. So we're going to go into our directions class. And we have here an enum for layer, up or down. So up's 1, down's -1. So then in our constructor, we can have our button ID and our direction, which is a layer. and then we can have our up and down direction. And then we just set our button ID and our layer direction. And then we have another constructor for if you want button activated, where you'll click it and it just pulls it up, and then you just move the button around as opposed to holding the mouse button. Then we're going to have a method for setting button activated, so you can set it later. And then we have a method to check to see if our click is over our current sprite. Now I'll update the update method first. First, we're going to get the current X and Y location, setting that to our X and Y update locations. And then we're going to check to see if that is over the sprite. So I'll show the non-button activated first. So what we do is you just press the button. So now you've activated it, you're triggering it, you're active. We're getting the click offset. So we want to know where on that actor that you're clicking, so that as you move the mouse, it will stay at the kind of that same location. We now update our layer to the new layer. We add our lock so that no other actor will respond to clicks on our button. And we set our start and XY location. So if we have a collision, it will snap back to that starting location. So in our button activated scenario, if we're just clicking the button, we're either activating or deactivating. And so we just do active, do the opposite of what's currently is. If we're activating, we get our click offset, get that set. We update our sprites layer, and we add our input lock for our particular sprite. And for deactivating, we set it to our triggering mode, and then our sprite update, we're going to set the layer back down, and then we're going to remove our button from our input locks. So if we're active and our button is not activated, we're going to check our screen inputs to see if our button is still being pressed. And if it's no longer being pressed, then we're setting our triggering to true, and we're going to set our layer back down, and then we're removing our lock. And if we're now active and we're still triggering, this is where we update our sprite's X and Y location, and we set those. Otherwise, we set our X and Y updates to be 0 so that our speed ends up being 0. So I've made some updates to our framework. I've added a base mouse movement. He extends the base movement, and this has the activate, button activated, button ID, the X and Y, click offset, a base constructor setting that button activated, and a protected method for is over actor. And so is over actor was in this class. I removed it out. This is the mouse drag, and I moved out those common attributes and the common method. So now this extends base mouse movement. And I've also updated the mouse layer drag movement to extend that base mouse movement. So I pulled out the attributes and the method that are now in that class. Next, we need to implement our handle collision method. So we need to handle a collision for if we're triggering. This is clicking the mouse button. So either it's coming up or down a layer. And so we need to check to see if we're active. And otherwise, if we're button activated. And so the triggering is for reverting our layer movement, and this is for reverting all of our single layer movement. And so if we were in an active state, this is mean we're going to go from inactive to active. And so what we need to do is reverse our layer movement to the opposite of our layer direction, and we want to remove our lock for our button ID. And then we set our active to be false. Now, otherwise, we're in a button activated state, which means that we have a grab on to our sprite, and we're trying to go to an inactive. And so we're going to reverse our layer, and we're going to cancel our remove. So we collided, so we can't go to an inactive state. So we're stuck in an active state here. And then we also need to handle collisions related to being in a single layer. So if we're no longer active, and we're not button activated, which we're just dragging the mouse around, and then we need to set our X and Y location back to our starting X, and our sprite updates Y location to our starting Y. Otherwise, we're just going to set our X back to our X update, Y to our Y update, and then we do a check to see if our mouse is no longer over the sprite. And so we'll set our active to false. Our X and Y update will be reset to 0. Now we're back in our checkerboard screen, and now we're going to use our new mouse layer movement. There it is. Set our input left. We're going to set our direction. We'll go up. At this point, we'll just do a drag. So we'll click, and then we'll be able to drag it around, and then when we let go, it'll be laid back down onto the screen. Okay, and our red chip is added first, and our black chip is added last. So the black chip is actually going to be rendered last. So we'll run it. Here's our two chips. Click on the red one. I let go. He sets back down. I can move him around, and if I try to, now you see the red one is added first, so he gets rendered first. So that's why he appears below the black chip, but he's not colliding because he is in a different layer. And if I let go, it'll pop back to where he was before. And then the black chip, same way. And see, he was added last, so he renders on top. And now I'll set it to be button activated. Okay, and now when I click on it, he drags. I don't have to hold the mouse button. And I click it back. Let's go. Look at this one, set him down. If I try to let go here, it doesn't deactivate and I still have it. And conversely with the black, same thing. And I set it back down. So the next thing we need to do is actually implement layers into our game screen. So to integrate the layers, first thing we're going to do is pull out the code for storing the actors, the updatables, and the sprites. And to do that, we're going to create a game map. So the simple screen that we were using before is going to be put into our game map. And then our base screen, we're going to update it, and so that it will contain the game map and some elements from our base, or some elements from our simple screen. And so the add actor and add decor method, we're going to remove those. We're going to keep the updatables at this point. And we're going to have a game map. It's going to be an abstract class. It's going to keep track of the render cycle and sprites that need to be added. We'll have an add actor, decor, and sprite method. Those will be abstract, and so the individual game maps will implement how the sprites are added to the game map. Then we'll have a render cycle. The render cycle will set our flag to true for the render cycle. We will update all of our sprites, and then we will draw our sprites. The render cycle will be turned off, and then we're going to add off cycle, which is adding these sprites in the list that's to be added. And add off cycle is an abstract method. Draw sprites and update sprites are abstract methods as well. So back in our base screen, we're going to add a private attribute for our game map. We'll add a setter method. Then we will remove our render child method, because that now will be used in the game map. And so in our render cycle, after we update our background, then we'll do game map dot render cycle, passing in the delta and the batch. At a point in the future, we'll actually move the background into our game map, but I won't do that at this time because we're focused on getting those layers. And so here in our actor factory, we would update this to be a game map. And we'll have a game map attribute. And so both our constructors in the actor factory will take the game map, and the create new actor method will add the actor to the game map. Okay, and then we're going to add a simple sprite map. It's going to extend our game map. And this game map is very much like that simple sprite screen that we were using before, as a list of sprites. Creates the initial array of sprites. You can add an actor, a decor, and a sprite. And if it's in the render cycle, it'll add it to our to be added list. Otherwise, it adds it directly to the map. Adding off cycle just goes through our to be added list. If there's any entries, drawing the sprite, just loops through the sprites and draws them. And the update sprites will loop through the sprites and to call its update method. It'll do a detect collision and then checks to see if the sprite needs to be removed. It will remove it. Here's adding our sprites to the map, just adds it to our sprite array. Detect a collision is just taking that sprite and comparing it with every other sprite in the array to see if it has collided. Now we're going to update our checkerboard screen. So simple screen went away. So we're going to add our base screen here. And in our show method, we need to add our simple sprite map. And we need to set our game map into our screen. And then here, instead of just doing add actor, we're going to do map.addActor. And then we'll give it a run. And here are our two chips. So I got this one picked up. I can't put it down. And then this one, I can't put it down there either. And then we will test it with our button controlled layer setting. So try to let go and it'll snap back to where he was. So that still functions as it did before. Now we will add layers to our simple sprite map. And just as a note, I had created this simple render map, which extends that game map, and it creates this render method that takes the delta and the sprite batch, and the render cycle just calls it. And so all of the other classes that I had for the tutorial are now using this simple render map. And so we're going to add our layers into our simple sprite map. And I'm just going to do that by creating an array of these sprites. And we'll just call this sprite layers. And our constructor will take a parameter for layers. And we're going to add a mod count. And we're going to add an iterator. We have an iterator, and this is the iter class. It's based off of the array list iter class. You can find that within that code. And what it does, it has a cursor for the layers and a cursor for where we are within a specific layer. And so it just checks to make sure that we haven't exceeded all of our layers and within our current layer. The next does a commodification, checks our layer, pulls that list out, and then pulls out the element for our last iterator. And then we have a remove method, same basis. So it does our cursor, layer cursor, and does a remove on that particular layer. And we do check for our commodifications. Then our draw sprite method is going to use that iterator, loop through all of our elements, and if it's not removed, it will draw it. And so our update sprite's going to loop through our iterator and do the update as it did before. Adding a sprite just adds it to that layer based on what the sprite's layer is. detecting collision. Now we get the layer and we pull out that layer and we only loop through that layer to check if the sprites have collided. And now with our layers, we need to keep track of sprites that we're moving from one layer to the other. And so we're going to add this map here, which has the key is the layer and the list is the sprites being removed. Then we'll initialize it here. Then we'll update our add off cycle. We're going to loop through our sprites that are going to be removed, remove everything that's in each layer. And then we're going to update our update sprites. And after we detect collision, we'll check to see if sprite is changing layer. And then we'll add it to the to be removed for what the current layer is. And then to be added, we'll add the sprite, which is already updated with its new layer. Another thing we need to add is to our movement class. We're going to add a method is changing layer on collision. In our base movement class, we're implementing that method to always return false. Some other classes like the script movement and the no movement will have their own implementation to return false. In our mouse layer drag movement, we're going to add an attribute changing layer on collision. And then we handle collision. We will set it to false. And if we have a collision, which is falling through to this else block, we set it to true. Then in our actor class on our handle collision, after we check to see if we were collided, we then set our changing layer based off of the movements is changing layer on collision. And I think I'll probably rename that method, take out the on collision. So then in our checkerboard screen, we have our simple sprite map. We're going to set 2 layers, and the red chip was added first, the black chip is added second. So when I run that now, here's my red chip, he was added first. He's above the black chip, and he snaps back. The black chip is also now above the red chip, and he snaps back. I'm going to change these so it's click activated. We'll run it again. So I picked it up, set them down, pick them up, can't set them down here, set it down here. And there it is. We have our sprite layers. And we can now pick up sprites, move them around the screen, and place them back down, provided there is no sprite at that location where it's being placed down. So that's going to do it for this video, and we'll see you in the next video.